Hello there, Algebra 2 students. Here we are at the end of the day with the weekend ahead. Hope you all had a great day and that you're ready for a great weekend. I'm going to be going over this review sheet. You can, of course, pause if you need to, and I will have it posted for you to see later on as well. I'll put it on the Google Classroom. I will always also have it on my teacher website, sites.google.com/view kdowdy. You can see the web address up on the board, but you can find it in both of those locations. All right, so here we go. Different ways to solve systems of equations. Now, first of all, there are 4 different ways. I do have them printed out, but I just want to say it so that you've heard it as well as seen it. We looked at graphing, we looked at substitution, we looked at elimination, we looked at matrix. We also looked at tables. They weren't particularly useful, so I'm kind of choosing to skip over those. But I do want you to be able to say the usefulness of these different methods. So an advantage to each one that will be on your test for sure. Okay, don't forget, you can produce one note card. You don't want to take all of it up on one specific thing, but if you think you'll forget one of these methods, you might want to kind of jot that down. Graphing is good for if you want to find integer solutions, fractions, decimals, not so much. It is a little time consuming, but it also helps you to see the meaning of each one of the solutions. Substitution is good if one of the equations has a variable that is almost isolated. And for like the smaller type of equations, substitution can be a good option. Elimination, super convenient, especially if they're both in standard form and there's just 2 variables. Things will eliminate. With 3 variables, well, it does become a little bit cumbersome, as you found out in your work together assignment. And so we just know that that is something that's a bit difficult. We're not going to have the giant elimination substitution problems that you have to do on your test. However, you have to be able to solve them in some kind of a way. And then also matrices. Matrices are good if you're going to use a graphing calculator, if it's available, and also good for more complicated systems. We never really got into the row operations, which are great if you can do by hand and you don't have a calculator. But honestly, I think elimination and substitution are a little bit easier to do by hand. If you don't have that, the row operations are a thing, and that's great, but not really necessary for you at this stage of the game. Okay, so be careful in all cases, because in all cases, one little number can make a problem. So when you're doing these, make sure that you're showing your work so that I can give you part credit just in case you make a mistake. So it is required that you show what you are doing, even if it just means to draw out the matrix that you're using. Okay, determining whether they were dependent, independent, or inconsistent without graphing. You may not remember right now, but what that was is when you solve them for y, put them in y equals mx plus b form. So for example, this one, when you solve this equation for y, we get y equals 2/3 x minus 8/3. When this one is solved for y, you get y equals 2/3 x minus 8/3. And we find out that they're the same equation. When they are the same equation, they are dependent. And you just need to know independent, dependent, and inconsistent. We did have several terms, but these are the terms that you're required to know for your test. So if you feel like pausing it right now, or if you want to watch the whole thing through and then go through and do them more carefully, just listen probably for now would be great. And then this is available for you to slow down as needed. Once again, solve for y, so get y by itself. You'll move over the 4x, you'll move over the 5. You're going to, in this case, move over the 10 and divide by 2. So when we solve this one for y, we get y equals negative 4x plus 5. Solve this one for y, and we get y equals negative 4x minus 5. Same slope, different y-intercepts. That means the lines would be parallel, so it becomes inconsistent, which means no solution. This one, again, solve for y. Get the y by itself, move over the x, divide by 3. Here, if we divide by 12, we get that. Same slope, different y-intercept, inconsistent. If you went through and found that they had different slopes, then that would be where you would have independent. Okay, so you can look back in your notes. Any one of those 3 scenarios could possibly show up on your test. Okay, solving by substitution or elimination. Yesterday you practiced that a lot. This one, since the y's are already there, probably the easiest thing is to just substitute in. So in other words, this gets substituted in here, and then you follow your algebra to solve it. Taking away your 3x, taking away your 27, dividing by 9, getting negative 4. Plug the negative 4 into whichever one you want. Simplify. You get an ordered pair. You get x equals negative 4, negative 21. Over here, for me, I would eliminate. I would multiply the bottom one by 2. Like that. Top one stayed the same, bottom one by 2, so this eliminates. So we get 12x plus 2y equals 22. Add up your columns. So the x equals 2. That x then gets plugged into whichever equation you love. I like this one because the y is already almost by itself. 6 times 2 plus y. So y turns out to be negative 1, and your ordered pair 2, negative 1. Very nice substitution and elimination. If you remember also from the first half of the chapter, we have graphing the system of inequalities. Remember, we're only getting that V shape when you have the absolute value. Other than that, treat it like y equals mx plus b. So you would be starting here at negative 2 and going up 1, right 1. This one you'd solve for y first, move over the 4x. So when you move over the 4x, you're starting this one at negative 5, and then down 4, right 1. But you need to go up this way too, so up 4, left 1 is the same thing. This one is a solid line because of this. This one is a dashed line because no or equal to. Greater than, the dashed line one would put us up here. Less than, the other one puts us here, for this being our solution. This one, as you're aware, is another linear with a solid line. This will be dashed because no or equal to, and it will be a absolute value, so you would go left 2, down 3 for your vertex on that one. Here's what it looks like. This one comes from here, left 2, down 3. This one starts at 1, up 1 over 1. Solid line. The reason it's here instead of here, that both of them are a greater than. So greater than this line is all up in here. Greater than for this one would put us above the line. So the only place where both are happening are right here in the yellow shaded region. The next thing on your review sheet was the part that I told you to skip. So this you should cross out, and we're going to just scroll on by. Writing a matrix to solve, as you know, you put in the coefficients. I think you guys were fantastic at that, but just to show you one more time. This is the answer that you eventually get, but we would go into your matrix. We would edit your matrix. The matrix comes from the coefficients 1, -2, 3, 12, 2, -1, -2, and 5, 2, 2, -1, and 4. It's a 3 by 4 matrix. 3, oops, not 34. My goodness, that's a giant matrix. 3 by 4. We'll put in all of our numbers. Negative down here. Okay, and then 2, 2, 4. I am doing a little bit on the side keypad in the interest of time. All right, so our matrix is now entered in. And then we need to do some matrix math, but go out of there first so you're not putting it into one of the elements spots. Matrix. So the second of that, math. And go down to RF, which is choice B. We want to pick the matrix A that we just loaded it in. Hit enter. And these ones mean that X is 4, Y is -1, and Z is 2. If you would need to make, if it happened to have some decimals in it, you could use your math and fraction on the whole matrix. Okay. There will be a couple of word problems very, very similar to these word problems, so we're going to take a look at them a little bit at a time. $25 and $1 bills, $5 bills, and $10 bills. There are twice as many tens as fives. Number of ones is one more than the number of fives. How many of each bill did you have? Use a system, show your work. So on your test, you can label your variables and then write a system. You have to do that part. Once you have the system, you can either solve it by substitution elimination or matrices. I guess you could graph as well, but that's the hardest way, so I don't expect to see any graphs. So let's just use X and Y and Z because we're used to it and assign it a label. So X is our number of $1 bills, Y our number of fives, Z our number of tens. Altogether, we have 25 bills. So if we add up these three, we get the 25 bills that we have. We have money equations. Also, actually, we don't have a money equation here, do we? There are twice as many $10 bills as $5 bills. So there's going to be more of the 10s. We'll take our 10. Z is 2 times the 5s. Number of 10s is 2 times as many of the 5s. That would imply that there are more 10s, which is consistent with our wording. The number of $1 bills is 1 more than the number of $5 bills. Number of $1 bills, X, is Y plus 1. So we have our 3 equations. You could do a matrix if you want. I personally think it's easier to substitute, but I'll show you the matrix in a minute anyway. Because what you can do here is you can take Y plus 1 and put it in for X. You can leave the Y alone, and you can take Z out and replace it with 2Y. And we've now used all 3 equations, but we can just put these together. 1, 2, 4Y plus 1. Take away your 1. Plug that in. Plug that in. And this question is finished. Well, maybe not entirely finished. We know what X and Y and Z equal, but we need to find the question, how much money do you have? So if I know that X is 7, I have 7 $1 bills. That's $7. I know Y is 6. I have 6 $5 bills. That's $30. And I know Z is 12. That's 12 $10 bills. So that's $120, which we would then add up. $7 plus $30 plus $120 ends up giving you $157. Okay. As I said, I know some of you really love to use matrices. I think it's a little harder in this case, but let me just make sure that you know how to do that. Copy and I'll put it on one of these. All right, if we wanted to use a matrix on this, we would have to move it around a little. This one stays the same. This one, we want to move the Y over equals 0, because I took the 2Y away from this side, and that left with nothing over here. Here, I would need to move the Y over like that. So your matrix will be this. 1, 1, 1, 25, 0, and 1, negative 1, 0, 1. I'm going to load that into the matrix. Okay, we know how to do that already, so we'll do that with the thing on pause real quick. Edit, and I'll put those in. Okay, and hopefully, as you can see, I've got that matrix put in there. Now we're going to do the RF. So go out, back in, matrix math. enter on RF, pick matrix 1 or matrix A. We go here, here's our 7, our 6, and our 12. Just like we got here, 7, 6, and 12. Okay? All right, so the key thing to using the matrix is to move it all over so that you've got all the variables on one side and all the numbers that have no variables on the other side, all the constants on the other side. Let's take a look at this last one. You spend $378 on books and access codes. And yes, that is the thing. Sometimes you will get an electronic book and they will give you access codes to how you can do your assignments. So you have to actually buy those and then you don't get to keep them. So it's kind of annoying. But you might have to buy books and access codes. And together you buy 7 items. Okay. Books are $78 each and access codes are $22 each. So altogether we have B is the number of books and C is the number of codes. Of course, any variable you like would be just fine. B number of books, C number of codes. Together you have 7 items. B plus C is 7. In terms of money, the books are $78, so 78B, 22C, because each code costs $22 and altogether that's $378. So there's your money equation. Once you have this, you can solve it in any way that you want. You can use substitution, you can use elimination, you can use matrices. Okay, here I chose to solve for B and substitute in just for a way of handling it. So substitute that in, distribute, put together your like terms, subtract from both sides. We got C. C is the number of codes, so if there are 3 codes, you ended up with 4 books. And that's it. That's how that goes. Remember, you can play this as many times as you want, as slowly as quickly on your own time. Make a very good note sheet for your test. On Monday, you will start your test. You'll have Tuesday as well. At that point on Monday, I will also be giving you back your work together quiz for more feedback. We can take a couple minutes for additional questions, but these are the things that you're responsible for, what I just went over on that. All right. All right, we'll see you on Monday, ready to start doing an amazing job on your tests. I'm super proud of you all. Have an amazing and wonderful weekend. And thank you for subbing today. Really, really appreciate all the help. And hopefully by now, Dave is out of surgery and doing great. All right, bless you. Have a great weekend.